Okay, this is just a quick video, an intro video to A2. So it's just kind of carrying on from the first part of this unit about limits, but now we're going to just have an introduction to derivatives. So now we're actually getting into the calculus side of things. Okay, so we're going to take this thing a step farther. So remember this, how we calculated instantaneous rate of change? So we took a graph and we wanted to find the slope at one point. So we called that a tangent line. And we want to find the slope of that line, the slope of this purple line, at this specific point here. And since we can't just use one point to find our slope, we picked another point on the line, on the blue line, and we just said that when we were doing rise over run, we said this was h, and this is our top, so f of a plus h minus f of a. So we said, we want to find the slope of this line as h approaches 0. So when h is at 0, we'll be finding the slope right at this one point. So this is just all about finding the slope at one point on a curve. So that's our goal here. Curve, and we're trying to find the slope at that one point. So we're going to be using this equation that we learned in class, but we're going to use it to generalize about an equation or a function. So let's just define what a derivative is. So here, a derivative for a function, y equals f of x, the derivative is the slope of the tangent to the graph of y equals f of x at x. So it's just exactly what we said. It's just the slope of this line. And the instantaneous rate of change of y with respect to x. So it's just telling you it's your change in y over x. So we're just going to change this formula slightly to be a derivative, and we're going to call this thing first principles. So it's just going to be a more generalized version of the top one. So from first principles, we can determine the derivative of a function, so the slope of the tangent line, and we'll call that f prime x. You can also see it written as dy by dx, the change in y with respect to x, and some people use the notation y prime. I think this guy is the preferred notation. Okay, so we're going to use the same thing, so limit as h approaches 0, but instead of an a, I'm just going to switch it to an x. So it'll be x plus h minus f of x over h. So let's try it. Let's find the derivative of a function. So say we just had the function x squared, and we want to find the derivative of that function. So if we wanted to find f prime of x, we're going to use this formula from first principles. So we know our denominator is 0. So we just need to know what's f of x plus h and what's f of x. So we can fill that into our formula. So f of x is just x squared. That's what it says here in the question. And f of x plus h, well, wherever I see an x, I'm just going to replace it with an x plus h and then squared. Since my function is x squared, I just added the plus h. Okay, so then I've got, since my formula is f of x plus h minus f of x, I just sub that in. So I have x plus h squared minus x squared. So then I simplify my numerator, so I get x squared plus 2xh plus h squared minus x squared over h. I notice x squared minus x squared goes away. So all I have is the limit as h approaches 0. I notice each of these terms has an h, so I'm going to factor that out. So I get 2x plus h over h. Cancel out my h's. And I get 2x plus h. Then, since I'm finding the limit as h approaches 0, I'm going to go ahead and sub 0 in. So I get 2x plus 0, so 2x is my answer. So it turns out the derivative of x squared is just 2x. So if we notice, the original function x squared was a quadratic function, and the derivative of a quadratic ends up being a linear function. So now we can say, like, this graph y equals x squared. We know the slope of our tangent is 2x, or our derivative. So if I wanted to find the slope at, say, when x equals 3, if I wanted to find the slope of my tangent line, I would just sub 3 into my derivative. So I know my derivative is 2x. So I would just sub 3 in for x, which would be 6. So now I know this line has a slope of 6. Okay, so you can do this with any equation now. So let's just try another easy one. So let's say f of x equals x cubed. So if we wanted to find the derivative, let's use this notation. dy by dx, finding the change in y with respect to x. So we're using the limit as h approaches 0 for f of x plus h minus f of x over h. So I just have to sub all that stuff in. So f of x plus h, so that's like just sub x plus h into your function. So this is your function. So I'm going to sub x plus h into my function, cubed, minus f of x is just x cubed over h. And then if I expand all of that stuff, it's a little bit more work because if I have to expand x plus h to the power of 3, then I will get x cubed plus 2x squared h plus x h squared plus x squared h plus 2x h squared plus h cubed. So that's expanding the whole bracket, and then minus x cubed. So that I just x plus h, x plus h, x plus h, and you can just expand those brackets like that. Or if you remember how to expand it using like the binomial theorem. Okay, so all that stuff over h. So then if we simplify that, limit as h approaches 0, the x cubed minus x cubed, that goes away. And then we got an x squared h, another x squared h. So we got this guy and this guy. So we got 3 x squared h's. Whoops. 3 x squared h's. Then we got xh squared, 2xh squared, so that's 3xh squareds plus h cubed over h. And since every single thing has an h in it, I can cancel out one h from every term. So then I have limit as h approaches 0 of 3x squared plus 3xh plus h squared. And now if I just throw a 0 in for all my h's, I just end up with 3x squared. So I know the derivative of x cubed is 3x to the power of 2. So if my x cubed graph looks like this, so a polynomial function, then my derivative of this is a parabola, crazy. Okay, so if you want, you could try a tricky one, and we'll take this up in class on Thursday, but if you want, you could try 1 over x. See if you can find that derivative of 1 over x using first principles. So using this limits formula, x, so subbing all that in. So for example, this guy, f of x plus h, wherever you see an x, you're just adding the plus h. So this would turn into 1 over x plus h, and this would just be 1 over x. Yeah, so give it a try, see what you get for your derivative.